Amplitude and midline. The midline of a sinusoidal function, so either a cosine or a sine function, is the horizontal line that is vertically equidistant from the top and bottom of the graph. So I can see for the cosine function that it is starts at -1, right, and ends at 1 in terms of its height. So that midline is just going to go right in between there, kind of cuts it in half. And same for the sine function. So they actually both have the same midline, and it is the line y equals 0, in this case, the x-axis. The amplitude of a sinusoidal function is the vertical distance from that midline to the highest or lowest part of the graph. And that should be the same distance, whether you're going to the highest or lowest part. So I can kind of zoom in on both and show you that. So here is the highest part, or the peak, and if I measure that distance, right, this should just be 1 unit. I could do the same thing going down to the trough or the bottom of that valley, and this length here is just as a value of 1. Okay, what about the sine function over here? Same idea, right? Value of 1, value of 1. But notice, even when I'm measuring down, I'm still saying that the length has a value of 1 because I'm talking about a distance. So I can see that the graphs of cosine and sine both have an amplitude of 1. Okay, so we can use that when we think about drawing these kind of basic graphs. So in order to graph transformations of sine and cosine functions, we need to feel comfortable creating the parent graphs of sine and cosine. So what we mean by that is y equals cosine of x and y equals sine of x. So we just did that using tables, and we had the unit circle involved, and it took us quite a while to make that graph. And so now that we're familiar with that shape, we really want to be able to make at least one period pretty quickly, and we're going to use 5 key points. So I'm going to label this y equals cosine of x, y equals sine of x. So again, here I'm just practicing making these graphs with no changes, no transformations introduced, using the fact that we have a midline of y equals 0, amplitude of 1, and we know that the period of each of these is 2 pi. So I'm going to use these 5 key points. So first I'm going to make an axis. So I'm just going to make my vertical axes and horizontal axes, and 2 pi is the period here, and the midline is y equals 0, so I'm going to start there. My max is going to be 1 and min is going to be -1, and so I just have all of that drawn in there. Okay, so what I like to do is use a box. So what I'm going to do is just use a highlighter or a dashed line or both to draw in that midline. And then I'm going to draw the box at the start of a period, which I'm just going to use x equals 0, and x equals 2 pi is where the box will end. And then the top of the box will be at the top of the graph, and the bottom of the box will be at the bottom of the graph. And notice that the midline cuts right through the box. And then I'm going to draw the 5 key points of the one period of cosine of x inside. Now I saw that the cosine function kind of looks like a bowl. So a bowl or a vase. So the bowl starts and stops at the top. The bottom of the bowl is halfway, okay? And then between the top and the bottom, the bowl cuts through the midline halfway between the top and the bottom. So it's going to look kind of like a little V, but I know that I need some curve action here on my cosine. Okay, and I can see that nice symmetry there. And this is one period. And I notice these 5 key points. But notice that I'm not plotting them knowing like, okay, this is 0, 1, this is pi over 2, comma, da, da, da. What I'm really graphing is really just their location within the box. And that's going to help me graph these functions as they get more complicated. Let's do the same for y equals sine of x. So y equals sine of x, I'm just going to draw one period. So I'm drawing in my vertical and horizontal axes. I'm going to draw out my scale to 2 pi and my vertical scale to 1 and -1. Okay, I'm going to draw the same box. So what is the box? One box has the length of a period. So this is 0 to 2 pi. Where do I want to start it? Well, I'm going to start it at x equals 0 unless there's some kind of shift or something happening. So here we go. The midline is going to cut right through the top, right through the middle. And then what I notice is that the amplitude here is 1. And so the amplitude I know is the distance from the midline to the top and the distance from the midline to the bottom. So the box should actually be has a height of double double the amplitude, right? Because I need room above the midline for the amplitude and then below the midline for the amplitude. So there is my box. And now if I want to draw in my sine function, I know that the sine function is a hill and a valley. So the hill takes up half of it, and then the valley takes up the other half. So for the first half of the box, I need the hill. So in between the start and stop of the hill, I have the peak of the hill. Nice and rounded, no points, right? And then the valley is just going to be dropping down where the hill was popping up. And so here are my 5 key points that fit within the box. Now I can label them just based off my scale, right? I can see pretty easily. I go, oh, I see that this is just pi, comma 0. And I can label them like that just by, the way that I labeled my axes. But I'm really drawing these boxes of one period just by knowing the shape of the graph and where the midline is, right? So that's where the center of the box should be. The top of my box should be the height of my graph. The bottom of the box should be, right, the bottom of my range, right? Top is the top of the range. It starts at x equals 0 unless I have some kind of weird shift, and then the length of the box is the length of my period. So we're going to use these boxes when we do this graphing transformations. When we start making a bunch of changes, it's going to make it a lot easier because we can always just go back to the box. So the box might get skinnier, it might get shorter, it might get taller, those kinds of things. We might move the box around, but once we know where our box lives, then we'll be able to make these graphs.